Alright, so today we'll be deriving the 1D classical wave equation. And this will be part 1 of the series where we will be deriving the wave equation, finding its solution, and we'll be using that to do something interesting, and I'll be deriving the Schrodinger equation, the 1D time-independent one. Okay, so now let's begin. And before we start, it's best if you guys know a bit of calculus, at least for this part. You guys will be needing knowing how to do differentiation, and the next one will be knowing how to do integrals and differential equations. Yeah, so let's start it now. So here we have a wave, right? And this wave starts from 0 and ends at, let's say, L, right? And the distance from here to here, we'll just call that x. And here we have u of x of t, right? And what this tells us is, what this function says, right, is basically the position, let's say a particle on this wave, right, located on this wave, depends on the position of, well, where on the wave we are currently and what time. So u of xt is what describes where the particle is on this wave. And there's actually well, two other ways of writing this function. We can write that as fx plus vt. So obviously it still has the two variables x and t, right? It's just a different way of writing it, and well, you'll get a different function, because think about it now, you have, well, the x, right? But then at the location x, you have a change in x, which is determined by t. So it's different ways of writing it. And notice how x plus vt, x minus vt will use the same function, but yeah. So now, using these three functions, we could derive the 1D classical wave equation. And the wave equation is actually a differential equation with second derivatives. So let's find out right now. So step 1, we're gonna try to find what is du dx. Okay, so I ignored xt for to make this more clear and to make it easier for me to write. So we have du dx. Now, what is this equal to? This also equals to f of x plus vt with respect to x. Now, what we're going to do now is we're going to use chain rule. Okay, so notice how, yeah, we did a chain rule here, and notice how this part equals 1. Here, this is 0, this is 1. So we will write this as okay. So now let's do the same thing, but this time we're gonna do this with respects to time. So same function. My writing's getting a little messy. Oh wait, with respects to time. So we'll do the same thing with the chain rule. You know what? I'll just write it out for you. Okay, and notice how this time is with respect to t, and this will be 0, and this will be v. Alright, so we'll get times velocity. So now that we see this, right, what we could get from these two equations is that and you could pause the video if you want to think about this a bit, and I'm going a little too fast for you, but yeah. So now let's do it for the other situation where it's x minus vt, right? So, well, basically what you do is you do the same thing, right? But you get x minus vt, right? So then here, right, you have a negative sign, and over there you also get a negative sign. So sorry about that cut. The phone is running out of batteries, but as I was saying, for the case where we have x minus vt, this will have a negative sign and this will have a negative sign, right? So we could write this as, well, it's the same thing, I guess, because this has a negative, this has a negative, you cancel the two out. Okay, so we have these two, right? But in order to find the general solution, right, we kind of have to multiply these two together. So, well, let's just do that real quick. Okay, and notice how, okay, this part of the derivation is a little sketchy. I don't think this is the proper way to do it, but this is how I understood it the first time I saw it. And yeah, well, the end result will still be correct, but this might not be entirely mathematically accurate. But okay, here we have du squared, dx squared, du squared, dt squared, right? And notice how this is not an actual second derivative. Because, well, the bottom is right, but the top is supposed to be d squared u, right? Not tu squared. So what we're gonna do is we're gonna divide both sides by du, and we're just gonna get Yep. Okay, so now we're gonna take the whole thing, right? And we're gonna find the difference in u. Okay, so now we officially have and this, my friends, is the classical wave equation in one dimension.